product is about the thermal properties of glass and Madar fiber reinforced composite laminates. We created the composite laminates with the use of glass and Madar fibers, and then we tested the thermal properties of that. This is our presentation layout. Nowadays, researchers are more concerned about the natural fibers as they give high mechanical properties like tensile strength, etc. So we decided to study the thermal properties of that. As I said earlier, the main objective of our project is to study the thermal properties of glass Madar fiber reinforced laminates, composite laminates. We used the polyester resin for these composite laminates. These are some of the literature papers we have studied, survived. This is our methodology. First, we selected the materials and then we fabricated them. For fabrication, we used hand layout method. Then we tested for thermal properties, and finally the conclusion. Materials used, as I said earlier, we used Madar and glass fibers. The resin we used is polyester resin, and as I said earlier, the technique we used is hand layout technique. These are some of the tests we have made. This is our timeline, project timeline. We took 4 months to complete this project. These are the fibers, glass fiber and Madar fiber. The thickness of them is approximately 1 mm. These are the resin and hardener. Hardener is MEKP, that is methyl ethyl ketone peroxide, and resin is polyester. This is a mold we use to fabricate. Fabrication, we use the hand layup method. It's a molding method, and we use the curing time as 24 hours and 350 pounds per square inch. Actually, we made 4 sequences of the materials: Madar, glass, Madar, glass, Madar, Madar, glass, 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 Madar, Madar, glass, Madar, glass, glass, Madar. We differentiated the properties of these and we studied which is better and which is least. This is a hand layup method. Actually, we will be using a mold and a roller. We'll be fabrication process. This is the work we have done, fabrication process, and this is our approximate expenditure. This is the test we have done: thermal conductivity, heat deflection temperature, coefficient of linear thermal expansion. Thermal conductivity, as we know, thermal conductivity is tested with a DTC 300 mission. And we need material size 50 mm diameter and 10 mm thickness at the constant temperature of 55 degrees centigrade. This is the mission we used for studying thermal conductivity. Heat deflection temperature, we know that heat deflection temperature is studied using 3-station HDT machine, and the constant, we test the heat deflection temperature constant load, and the load we used is 1.8 megapascals. This is a mission. Coefficient of linear thermal expansion, dilatometer is used to test this property, and we maintained a temperature between 30 and 70 degrees centigrade. This is the dilatometer we used. Results and conclusion. Finally, the results, as you can see here, no two sequences have the same properties. We can conclude that the properties differ according to the sequences. Some properties we get more for one sequence, and for other we can get less. According to the properties we acquired, we apply them in different fields. For example, here the thermal conductivity of MG sequence is more. and the least thermal conductivity we have for MGGM sequence, and so we can use MGGM sequence as an insulator. Similarly, this is the comparison graph. Similarly, the other properties also differ, and according to their properties we apply the materials in different fields. Thank you.